All right, good afternoon, everybody. So just a quick announcement, there is no lecture this Friday. So we start reading week a little early, and I'll see you on the Monday after reading week in our next lecture. Okay, so today is the first lecture where we talk about C programming. So we're moving into the second part of the course. So first of all, what is C? So it's a general purpose, compiled procedural computer language. So general purpose meaning it's suitable for different applications. So it's not targeted at any one particular application. Compiled, which for many of you, you haven't really seen or had to explicitly compile the program before. This is the first time we're going to do that for many of you. It's procedural, so like Python, like Python and sort of like Java, which has methods, this thing has functions, which you can call. It's a structured programming language, so it has things like loops, conditional statements, and things like that. If you've done any Java, you'll be pretty familiar with the core language. It has a static type system, so that means when you make a variable in C, the compiler knows what the type of the variable is. Right, so it's not like Python where variables can hold any values. It's more like Java where variables hold a particular type of value. And it has recursion. You'll often see that C is referred to as the high-level language. So high-level meaning you've got these things like programming constructs, right? Like loops and if statements and things like that. That's as close to the machine as possible while still being architecture independent. So when people say close to the machine as possible, they mean that the types that are in the language map closely to the types that your processor, your CPU, provides. So it has things like ints and doubles of a particular size, I guess. And the basic constructs like looping and if statements can be easily translated into the hardware on your computer. So for example, it's not like Java, where as soon as you say new something, a whole bunch of stuff happens underneath the hood. In C, everything happens at a much lower level. Okay, so if you're interested at all about the history of programming languages, that is a fascinating read, this article right here. I'm just going to quickly go over a few highlights from that article. If you're not interested in history, then I guess it's a lot less interesting. But where did that web page go? Sorry, it's here somewhere. Where'd it go? See history, here we go. Okay. All right, so this is written by the person who actually designed the original language. So it's by Dennis Ritchie, who used to work at Bell Labs, which is the old, I guess Bell Labs, so they're basically Bell in the United States. You know them as Bell Canada here. In the US, it would have been Bell, the telephone company. So there's some interesting things about this. So if you wonder where stuff like plus plus and minus minus comes from, it comes from C. If you're curious about where to go, I just want to quickly find some other stuff here. Here we go. If you wonder about how the assignment became the equal operator, it also came from C. Right? It used to be the case that when you did assignment, it would be written as this. So you probably haven't programmed in a language called Pascal. Pascal used to be a very common teaching language. Its assignment operator looked like that. The reason why that was often used in teaching programming languages is because the equal sign looks like the mathematical equal sign. And people who are new to programming confuse the two things. Right? So if you say x equals y, you think that x and y have the same value. And it also doesn't matter which way you write x equals y mathematically. Right? Y equals x means the same thing. Assignment means something very different, which is why there used to be a different operator for it in most programming languages, the teaching programming languages anyway. C dropped that, and it's been controversial ever since. Right? The commenting style from Java, /*, and //, that all came from C and its predecessor languages. If you wonder where array indexing came from, that came from the predecessor languages to C. Right? So that came from these languages called BCPL and B. So a lot of these programming things that we take for granted, a lot of these programming constructs that we take for granted today, they're all from the late 60s or early 70s. Right? Okay, so in 1968, this is basically where the start of the C language came from. So Ken Thompson was Ritchie was one of the two people who worked on the language. Ken Thompson was the first person to start working on the language. So way back in 1968, this guy Ken Thompson, he wanted to basically he wanted to make his own operating system and his own programming language. So he wanted to be able to easily program, well, comfortably program a computer. Computers back then aren't like the computers you have today. So I'm going to show you something in a second. Right. So this is the hardware that this guy was working on. So he had this machine, so it's called the DEC PDP-7. So, this machine had 8K 18-bit words of memory. So what that means is the amount of memory he had to work with was roughly 16,000 bytes. Right, that's how much memory was on his computer. Your cell phone has roughly 4 billion bytes. Right? So all this stuff all the programming stuff was born on a computer that had that much memory, as opposed to a device that most people carry around, at least in North America anyway, that has many, many, many orders of magnitude more memory. Right? So the amount of memory that he's working with is very small. That's the machine he's working on, or was working on. So that thing there is the DEC PDP-7. Notice its price, right? $72,000 US so back in 1968. If you were to buy, so in today's dollars, that's more than, it's almost 600,000 US dollars. Right? The article on this machine is also fascinating. So DEC is the company that made it. They're the Digital Equipment Corporation. They no longer exist. They're now part of Hewlett-Packard, HP. The PDP-7 is this thing here. Notice the information that's here. It was considered cheap, but powerful for the standards of the time. How many of these did they sell? So sales were considered to be highly successful. They sold 120 of them in total. Right? So that's what the early days of computing looked like. This wasn't even the earliest days of computing. Oh, if you want to know how it was built using this technique called wire wrapping. So all of the electronic components were connected by wires like that. Right? Unlike the circuit board that's in your modern computers today. Notice this thing has no monitor. Right? So there's a keyboard here. So you could type into the keyboard. If you needed output from this thing, you had to wait for the printout to come out. So that thing right there is a keyboard and a printer all in one unit. The other way to get information into this thing was via a tape. So a paper tape that's got holes punched into it. You would feed it into the tape reader, and it would read the holes that were punched into the piece of paper. And it also had magnetic tape. So these big reels of magnetic tape in which you would store and read information from. Okay, so in the late 60s through the 70s is when the language C was basically conceived, evolved, and then settled into its more or less final form. So the predecessor to C was a language called BPCL, from which B came, and then C came from B. So B is where plus plus and minus minus comes from. Ritchie and Thomas, they wrote the Unix kernel in C in 1972. So that's when Unix first started to rise in prominence. 73 is basically when the core of the C language was finalized, and then finally in 1978 they published this book here, which somewhat surprisingly is still the recommended textbook at a lot of universities for learning the C language, which is actually kind of sad because the language has come quite a long way since 1978. But this is still often cited as a reference. And it wasn't 1989, 1990, C became an official standard. So there's actually a body of people that governs the evolution of the language. C99, in 1999, the next major version of C came out. So we're largely using this one right here. In 2011, there was another version that came out, but the changes aren't major as far as we're concerned. And then 2017, there was another revision that fixed some stuff in the 2011 version. And this year, there's supposed to be a new version of C, a new standardized version of C that comes out. So there's supposed to be a C2023, right? We're only really concerned with up to C99. You're not really missing out past then on anything. Okay, so where's C used? So C is used where you need your program, so it's often used for something that has to be fast. Often the systems that you're building with C aren't enormous, but that's not necessarily true. You can build very large scale systems with C. And where things have to be fast and where that has to work closely with the hardware. So most operating system kernels are written in C. Mac and Unix and Linux kernels are all C. Windows is probably some C++ and C. Most embedded systems run C. So basically computers where there's no obvious input or output. So for example, the computers in your car are probably some variation of C. Many interpreted languages that we use today are actually written in C. Right? So your Python interpreter, almost certainly written in C. Perl, Ruby, and PHP, if you've heard of them, they're all written in the C programming language. Most programming languages, C is everywhere basically, so most programming languages can actually call C functions. Computer graphics applications are often C or C++, so all your video games are probably C++ or C. Anything that's computationally intensive is either C or Fortran. And many, many, many more. If you're building a really, really large system, C++ is probably slightly more common, but you can still build large systems in C. I don't know if you've heard of this index called the TIOB index. They're a company that basically ranks the popularity of programming languages. C has been the #1 or 2 language since 2001. It's currently #2 behind Python. C++ is #3. Okay, so in this course, you're going to need some way to edit or to create C files, right? So you probably want a C-aware text editor. Right? You don't have to use a C-aware text editor. You can just use a plain old text editor, but it's nice if your editor knows the C syntax. Visual Studio Code is one editor that's freely available everywhere, basically, that will understand C syntax. So if you want it, so in Windows it's easy to install. On Mac, you just follow that link, and you can figure out how to get it on your Mac. If you want to use Eclipse, you can in fact install Eclipse. If it's already installed, well, you probably don't have it installed in. If you're on Windows, I'm not sure if you can run it in Linux. It depends on which version of Windows you're running. I'm pretty sure you can do it in Windows 11. I don't think you can do it in Windows 10. So you can install Eclipse into Linux and then run it as a desktop application. If you're in Mac, obviously, you can just install Eclipse. You want to install the C/C++ version of it, so that'll give you the C development tools. If you want a debugger, the Eclipse debugger is much easier to use than anything else I'm aware of. If you're doing it from Visual Studio Code or from the command line, the standard debugger is very, very hard to use. So if you really want a debugger, I recommend you install Eclipse if you can. The debugger in Eclipse for C more or less works the same as it does for Java. Okay, if you need documentation, and you will want to read the documentation at some time, these two websites right here have the entire C standard library documented. online. The documentation is not as nice to read as the Java documentation is. It's a little bit harder to read the C documentation. I normally use the second one, but the first one's fine too. The second link also tells you about the language itself. Okay, so what does a C program look like? So it looks a lot like a Java program, honestly. So a simple C program is made up of some source code files, right? So normally these have the extension .c. Right? The source code, it's just plain text, so you can read it with any text editor, read or write it with any text editor. If you have any program that's even slightly large, will be made up of your source code files and something called header files. Right? So in assignment 2, I think, I asked you to write a little bash script that would make both the header file and a source code file at the same time. Right? So your header files have this extension .h. Your header files typically contain declarations of functions. So the header files say which functions exist, but they don't have the implementation of the functions themselves. The source code files are where the functions are actually defined. And so that's how a typical C program is partitioned. Right? Like Java, if you want to run a C program, you need a main function. Unlike Java, you can only have one main function. Right? So this is the typical one version of the Hello World program in C. Right? So again, it's just a plain text file. So you can easily edit this on any text editor. First line here, there's this statement that begins with a hashtag. It's include, and then it includes this file here. Right? Standard io.h, that's the header file that declares the standard library input and output functions. So it declares the functions to let you write stuff to the screen, read stuff from a file, and things like that. Right? There's our function main. Right? I'll tell you more about main a little bit later. Right? To print just a plain old string, you can use the function puts. Right? So this function puts is declared by standard io.h, which is why we can use it in our program here. Right? String in C, notice it's double quoted, so just like Java. Right? It's the double quote here, not the single quote. Right? The only strings in C are only double quoted, just like Java. Right? Notice the semicolon, so also like Java. This main function here says it returns an int, so it should return a value. So the value that's returned here is the value that's returned back to the operating system. So this is the exit status of your program. Right? So remember, your exit status of a Linux program, of a Linux command, should be 0 if the program or the command runs without any errors. So you typically, in a program that runs without errors, you want to return 0 here. Right. There is a second version of there's actually many versions of Hello World. So this version uses a different function to do the printing. So this is the printf function, or the formatted print function. So the way this thing works, that's the string to print. This thing here is called the formatting string. So what this does here is it looks for, in the formatting string, you'll see there are sequences of characters that look like % something. So %s means format this thing right here as a string, right? And so what does it format? What does it insert here? Well, it takes the argument after the formatting string and inserts it into here. Right? So it tries to interpret this argument as though it were a string and just inserts it into here. The \n means is the new line character. So this prints hello world and then goes to the next line and then exits. Right? You'll be seeing a lot of printf in this course. Okay, so if you write your program, you still can't run it unless you are in an IDE like Eclipse, or if you've got Visual Studio Code configured to automatically build and then run your program. Right? So if you're doing this all by hand, then you have to compile that source code file by hand. Right? So compiling is the process of transforming code written in one language and turning it into another language. Now, normally when people talk about compiling, they mean taking source code and turning it into something that the computer can run natively. Right? So when you're talking about compiling C code, usually we're talking about transforming C code into what's called machine code. Right? And so that's the code that your CPU can actually run natively. A compiler is simply a program that compiles. So you're also going to need a compiler in this course. There's many you can choose from. If you follow the instructions for setting up your computer already, everything's good to go. Right? So on Linux, you want to install GCC. You could also install CLang with LLVM if you wanted to. That's fine. On Mac, you're going to install CLang with LLVM. Right? So you should have already completed these steps if you followed the instructions at the beginning of the course. Okay, so to compile your program, you end up typing something like that into your terminal. So let's go ahead and do that. Right, so I'm just going to do everything by hand today. Okay, so here I've got my programs hello1 and hello2.c. If you want to look at them, we can. Right, so there's hello1. Right, that's the code that I showed you on the slide. And there's hello2. Right, again, exact same code. I can't run these programs yet, so if I try to type in something like hello1.c, it complains. Right? Even if you make it executable, it won't run. Right? It's just plain text. So you have to compile it. So GCC -o. Well, let's do it this way. GCC hello1.c, like that. Right? So if your program compiles successfully, you'll get no output to the screen. If you look in your directory, you'll see that there's something called aout, right? And it's executable. It's in green on my computer. So I can actually run aout, and it works. Right? So the default behavior of GCC, if you pass it in one or more C source code files, is to produce a program called aout. Right? So it takes hello1.c, compiles it, writes the executable program called aout. If you actually want to give it a more meaningful name, you just give it a command line option. Right? So here I'm going to use -o and hello1. So -o means produce the executable program called hello1, right? And compile the program hello1.c. Right? And now I can run hello1, just like that. Right? So you can do the same thing for hello2. Like that. And now we can run hello2, and away you go. Right? Be very careful when you're using the -o option. Right? So for example, -o will overwrite whatever you specify. Right? So if you say, produce the executable program hello2.c, right? It's going to compile hello2.c and then overwrite it with the executable program hello2.c. Oh, actually, this one doesn't. Okay, so it used to just overwrite it, but now I guess it's figured out that it shouldn't do that. So it won't let you overwrite the source code file, which is good, right? So that's nice. But be careful here. Whatever you specify here, it will overwrite.
Is there a way to go the other way?
Sorry?
Is there a way to go from that to C code? Or?
No. There's not with the compiler itself. I guess you could find a tool that tries to decompile C back to its source code. Oh, to run the programs, you just treat them as though they were a regular command, right? So they're in the current directory. If they're in the current directory, /name of the command. Okay, so let's take apart these programs one line at a time. So the first line in all of those programs was this include directive. So if you ever see something that starts with the hashtag symbol in a C program, that's what's called a preprocessor directive. So as part of the compilation process, there's something called the preprocessor. So it's the thing that reads your program and then does stuff as indicated by these directives. Right? So your C preprocessor processes C source code files before the compiler tries to transform the code into machine code. Right? The include directive, so what it literally does is it says, take whatever this file is and drop it into your program where the include statement is, or the include directive is. Right? And so what that means in this case, whoa, sorry. So, oh, wait, caps lock. Okay, so that statement right there causes the preprocessor to read the file standardIO.h, and it takes the entire contents of standardIO.h and places it right here. Right? So it plunks down a copy of standardIO.h into your program. And then the compiler reads all of that and compiles that program. Right? So an include statement simply includes other code into your program. So we need standardIO in this case, standardIO.h in this case, because it's the header file that contains the declarations of these functions puts and printf. Right? So in a C program, your program needs to, any function that you use has to be declared before you can use it. Right? Like a variable has to be declared. It doesn't have to be declared in the file that you're using it in. Right? So in hello1.c, right, there's no definition or declaration of puts. Right? So we didn't put in anything to indicate or to define the function puts. Right? All we did was use this include directive, right? And the include directive includes the contents of standardIO.h. It's standardIO.h that says there's some function called puts that's defined. Right? The actual definition lives somewhere else. Right? So the actual definition in this case lives in the standard library file that's linked to your program. Okay, if you want to comment in C, then it's basically the same as in Java. Right? So if you want a multi-line comment, it's /* and / around the comment. Right? From C99 onwards, you're allowed to use / as the line ending comment. Right? So basically exactly the same as Java. Every C program that you want to run on what's called a hosted execution environment has to have a function called main. Right? Main is where your program starts from. Right? There can only be one main function in your program. Hosted execution environment just means you're running it on a computer that has the full C standard library supported. Right? By contrast, a freestanding implementation is something that supports only a limited subset of the C standard library. Right? So for example, a lot of computing systems don't have any input or output. Right? There's no terminal or keyboard. Right? And so those would be freestanding systems. Right? They don't support the library functions that are defined in standard I/O. You have two allowable forms of the main method. Main function. Or the main function. Number one is int, main, and then void, and then the body of the function. Number two is int and main, and then int argcount, *, argv, square bracket, square bracket. So I'll explain exactly what these are a little bit later in the course. Right. This version of main, this is for a program that does not accept command line arguments. If you want your program to accept command line arguments, then it's the second version of main that you want to run. The language standard also says that compiler implementers are allowed to produce their own, or allowed to support their own versions of main. Right? But that depends on which compiler you're using and which computer you're running on, and so on and so on and so forth. So these are the only two that we're concerned with. Right. Okay, so what does that first declaration of the main method actually do? Right? Well, the name of the method, the name of the function is called main. It returns an int, right? So basically you read this like Java, right? It has no parameters, right? That's what the void means in this case. In older versions of C, you won't see void here. There'll be nothing there. Right? In newer versions of C, you're supposed to put in the void, right? So if your function has no parameters, the word void is supposed to be there. The reason it's supposed to be there is because if there's nothing there, then all you're saying is that there's some function called main that may or may not have some parameters. So the word void is there to explicitly say there are no parameters to this function. Right. Okay, puts is the function that you can use to write a single string. Right. So if you only want to write a single string, you can use puts. Right. It will print the string to the terminal and then add a new line character to the end, so it'll go to the next line. You can't print a number with puts. Right? So if you want to print anything that contains a number or, well, a number, I guess, you have to use something else. Right? So puts only writes strings. Printf is the more general version, is a function that will actually write whatever you want to standard output. So it's the formatted print function. So what it does is it loads the data from the given location. So that means anything after the first argument, right? You can have arbitrary number of arguments after the first, right? So that's the thing that's one of the things that you want to print, right? To print the first thing here, after the first argument here, you look for the first percent something symbol. It's called a conversion character here. So %s means format that argument as a string and print it as a string. Right? If you wanted to print a number or like an integer, you would use something like %d or %i, right, to print an integer value. If you wanted a floating point value, it'd be %f and so on and so forth. Right? So we'll explain more. We'll tell you more about printf later in the course. And then this function here says it returns an int, so we should return an int, right? And so the return statement there just returns 0, and that, if you run it in a Linux environment or in a Unix environment, sets the exit status of the program. Ooh, what time is it? Okay. Let me just pull up the next lecture, and we'll start in with we'll do a little bit of the next lecture as well. All right, so this is basically the basic types in C. Now, if you read the document that actually describes the standard for the language, it says that there are these things called objects. Now, you have to be careful about this, right? So C is not an object-oriented programming language, right? So these are not the same things as Java objects, right? In C, an object is just some chunk of data, right? So it's a region of data storage, the contents of which can represent values. Right? So in other words, when C says objects, it means some chunk of memory that represents a value. Right? That's all it means. Right? It's not like a Java object. So variables are one type of object. Right? Chunk of memory has a value. Right? So just like Java, variables have a type. Right? You have to specify the type when you declare the variable. You have to declare the variable before you can use it. So int x says that there's some variable named x whose type is int. Right? In C, x also gets a value. Right? So in other words, int x says that there's some chunk of memory that's labeled x that represents an int. Right? So that means that if you printed x, it would in fact have a value. Right? You don't know what the value is. Right? So this doesn't actually initialize the value, the variable x. Right? It just says x exists, it's somewhere, it has some memory. If you use it, if you try to use the value, it will have a value. You don't know what the value is. Right? So typically you want to initialize the variable as well, but you don't have to. Okay. There are other types as well. We'll talk more about the other types in a minute. C has functions. They resemble sort of like Java methods, but there are no classes or access modifiers in C. Right? The language standard does not consider a function to be an object. But curiously, right, in C, a function has a type. And what that means is that you can make a variable and store you can make a variable and you can store a pointer to a function in that variable. Right? So in other words, you can create a variable whose type is the same as the type of the function. And now you can effectively store a function in a variable, which means you can pass that function around to other functions. Right? So we'll talk more about this when we talk about pointers to functions. And speaking of pointers, this is probably going to be the most this concept is probably the one that people new to C have the most difficulty with. Right? So a pointer in C is a kind of variable. Right? So in other words, it has some memory and it has a value. Right? It stores a link to another object. Right? And in C, that link is the memory address of the object. Right? So it's sort of resembles a reference in Java. Right? However, with a C pointer, you can do a lot more than what you can do with a Java reference. Right? And so later, are we going to do anything here? So we'll talk about exactly what you can do with pointers later on in the course. If you want to make a pointer, then it's not hard to do. Right? So the type of a pointer is related to the object that the pointer points at. Right? So in other words, a pointer is a memory address of some other object. Right? So typically you know the type of the other object that you're pointing at. Right? So if the type of the object being pointed at is t, then the type of the pointer is pointer to t. Right? So here are some examples of making a pointer to an int value. Right? So the star after the type is the way to indicate a pointer. Right? So int star or int space star or int space star space, these are all saying the same thing. Right? So these are all declaring a variable called p, right, whose type is a pointer to an int. Yes?
Can you do no spaces at all?
No. You can't do, you can do, there has to be a space on either side, on one of the two sides, yes. Right. So there's no standard way of writing this, unfortunately. In C++, you will typically see int and then no space followed by the star. The Linux coding standard says you should use int followed by a space and then the star and then the variable name right after the star. Less commonly used is where there's a space on both sides of the star. However, they are all legal. Right? There is no general agreement as to which one should be preferred. Right? If you pick up two different textbooks on C, there's a good chance they'll use two different ways of writing the pointer. So I think typically, typically I'm going to write it using the second form. Okay, so C uses a mechanism called pass by value to transfer arguments to functions. This is just like Java. Right? So for example, in Java, or Python actually, you cannot write a function or a method that swaps the value of two primitive types for the caller. Right? So in other words, you can't write a method in Java called swap int x int y that changes the values of x and y for the caller. So for example, right? So this is a Java program here. Right? So I've got a static method called swap. Right? It takes in an x and a y, and it actually switches x and y. Right? Swaps the values of x and y. Right? What this does in Java is it takes the parameter x and the parameter y and switches the two values of the parameters. Right? So in other words, x and y, these are just variables that belong to the method. Swapping the variables that belong to the method doesn't do anything for the caller. right? So the caller's variables, x and y down here, right? When you call swap down here, their x and y doesn't change, right? So what happens is in Java, as in C, right, when you call a method or a function in C, right, the value of x gets copied into the value here, right? And the value of this argument gets copied into the second parameter, right? So in other words, right, the value 1 gets copied into here, and the value 2 gets copied into here. Right? So up here, x and y, their values get switched. So x becomes 2, y becomes 1, right? But that's all that happens. Nothing else happens, right? Down here, this x and y doesn't change, right? Because that parameter x is not that variable x. That parameter y is not that variable y, right? The exact same thing happens in C, right? So you cannot swap. If you were to write the equivalent function in C, and you were to call it from the main function in C, you would not see the change of the values inside the main function. Right? So there's the exact same function. There's the exact same program in C. Right? Notice it looks almost exactly the same as the Java program. So if you were to run that, you would just get 1 and 2. Right? X and y here don't change. Okay, so swapping the two values for the caller is not possible because the function never actually receives the variables that the caller has, right? It gets the values of the variables that the caller has. That's why it's called pass by value. If you use pointers, though, you can in fact arrange it so that the caller now sees the switched values. Right? So, for example, swap, right, now takes, instead of taking in an int, right, it now takes in a pointer to an int, right? So the memory address of some int variable, right? And instead of taking in y, an int y, it takes in a pointer to an int variable, right? So in other words, the memory address of some value, of some variable. Okay, on this line here, right? So remember x is a pointer to an int value, right? If I want to get the value that's being pointed at, you write star and then the name of the variable, right? The name of the pointer. Right? So that right there on that line, right, is called a pointer dereference, right? When you dereference a pointer, you get the value that the pointer is pointing at. Right? So this right here is in fact an int. Right? So star x is some int value, right, which I can store in temp. Right? Now, star x, right, so that's going to dereference x. So that's going to give me the object that x is actually pointing at. Right? I can now say that that's equal to the value of the object that y is pointing at. Right? So I've now assigned whatever value used to be in y, or is in y, to the object that's pointed at by x. Right? And then I can set the object that's pointed at by y to be equal to the new value temp. Right? Down here, when I call the function, right, I want to pass in x and y, right? But the function here is taking in a pointer, so I need the address of x and the address of y. The ampersand in front of a variable name is the address of operator in C. Right? So this says pass the address of x to the function swap, pass the address of y to the function swap. Right? Now swap switches the values of x and y. Swap switches the values of the objects that are pointed at by x and y. Right? So now swap knows that there's this x down here and there's a y down here. So it actually switches these two values here. And when you print the values here, you actually get the swap values 2 and 1. Right? And so this is one way that you can write a function like swap in a language like C. Right? If you can pass it the address of some values, then you can actually change those values. Right? So in that swap, so those two arguments, so the two parameters in swap, those are pointers to int, right? The memory address of some int objects. Right? If x is a pointer, then star x is the object that x points at. Right? So in this context, it means that the star is the pointer dereference operator. Right? We say that star x dereferences the pointer x, and that gives you access to the underlying object that x points at. Right? In this case, temp gets assigned the value of whatever object is being pointed at by x. Right? So in this case here, right, temp gets the value 1. Right? That line there says the object pointed at by x is assigned the value of the object pointed at by y. Right? And so back here, right, that x now gets the value 2. Right? And finally, star y equals temp means the object pointed at by y is assigned the value of temp. Right? And so in other words, that y now gets the value temp, which was 1. Right? And so these actually swap. Right? The ampersand in front of a variable name is the address of operator. Right? It gives you the address of the object. Whoops. Right? And so now you've got now you have a way to actually change the value of some variables that are owned by the caller. Right? There's other uses of pointers other than this. Right? And we'll see those later on in the course. I guess we should stop there because this is going to go on for a little bit to explain how scope works in C. All right, so just again, to remind you, no lecture on Friday. And I will see you after reading week.